Good morning, Raven families and Yukon-Koyukuk School District families. Welcome again. We are excited to have Kathy and Joe here again for another Math U Cube webinar, and we're hoping you enjoy it and you'll get to watch it at your leisure as well because it is being recorded. The 3-year Maxis project, which stands for Math and Computer Science for Students, was awarded to Yukon-Koyukuk School District in 2002 to promote student mathematical mindset and improve math computational performance through intensive teacher and parent-teacher, of course with homeschooling, training. Max's design is to improve mathematics is based on YKSD teachers, homeschool parents, and homeschool activity advisory teachers understanding the major mathematical concepts and skills of each grade band and the most beneficial and effective math teaching practices for those concepts and skills. Raven advisory teachers and Raven parent teachers will be trained and informed more on critical thinking or higher order thinking skills in mathematical instruction. The Maxis project also incorporates some of the best evidence-based approaches to reducing the very real fact of math anxiety that limits students' math achievement. Joe Bowler and Kathy Williams at UCubed out of Stanford are leading experts in the field, and we welcome them again today. Welcome, guys.
Thank you, Erica. It's great to see you. Welcome, everybody. Do you want to share?
Yeah, I'll share the PowerPoint. We'll get this math party started. I'm gonna have to find it. There it is. All right.
So I'm going to start us off and share that at UCubed we have been focusing for a couple of years now on helping young people in the world become literate with data and possibly move into more work in data science. You may have noticed that the world is now filled with data. This is just one statistic telling us that data is everywhere around us. And for young people leaving school, what they will find is that many of the, what we might call the top high-paying jobs, nearly all of them involve data, have data in the title. But any job that anybody goes into, they will be helped if they are able to make sense of data, because it's very important to any sort of work. As well as that, we firmly believe that teaching students to be data literate is an equity imperative. We know that as soon as students get online and are using devices or any sort of online contact, they are vulnerable to people sending them misinformation, and we want them to really be able to make sense of the information that is sent to them, to be able to separate right from wrong. Unfortunately, there are people who are deliberately trying to mislead young people and older people. And so helping students be able to make sense of the data that they see is really part of having a more equitable society. You may have learned statistics in your own education. Data science is a little bit different as you go up through the grades, especially as students get into middle and high school. They will be making sense of real data. It's not tables of numbers that textbooks make up, but real data, and that can come from local communities so that the students can be really invested with trying to help their community solve a problem using data from their own community. The discussions about the data tend to be a little bit more open than a statistics course. Typically in statistics courses, students are taught lots of methods and then they use them. But in data science courses, they usually start with a rich data set, and different students might ask different questions of the data. There's definitely more integration of technology that's pretty important in dealing with modern day data. So I got involved in a movement a couple of years ago when I got a phone call from somebody a bit outside of my usual realm, not in education, not in mathematics, but I got a call from Steve Levitt, who is a professor of economics at the University of Chicago. And you may know him. He's very famous for his Freakonomics book and work. And he got together this group of people. You see Nate Silver, is one of the creators of that great website that's done really well at predicting US presidential elections. People I don't normally hang out with, actually. So it was an interesting group. And he said, will you help bring data into students' education? So this is one of the reasons for this initiative. They put out a survey on their website and asked all the adults on their website to tell them what mathematics they used in their lives. And they got pretty stark data. As you can see here, this graph just shows if they gave the answer of daily or never. And what we see is a lot of the content in high school mathematics, algebra, geometry, trigonometry, calculus, most people say they never use, but the data, the mathematics of data, visualizing data, analyzing, using spreadsheets and databases is very frequently used. The Freakonomics people, Steve Levitt and his team, were a little bit worried that this was selecting from people who go to their website, which is mostly kind of STEM people, mostly males, men. So I repeated this survey with a large group of educators and got almost identical data, as you can see there. In fact, this puts the two surveys side by side, and you can see there's very little difference between them. Most people don't feel that they use the mathematics of their high school years, but definitely really appreciate the mathematics of data and data literacy and data science. So we've seen over the last few years some big changes. Started in California, where the University of California and the California State University system sent an email out to every high school in the country saying that they would now value students taking data science as highly as taking a course in Algebra 2 in high school, and really signaling for schools that there can be different mathematics pathways. There's nothing wrong with that pathway to calculus, but there's no reason we should only have that one mathematics pathway. Mathematics is a very broad subject, and that mathematics pathway to calculus has not been very equitable or appealing for many people. Very small numbers of students take it. So this new pronouncement from the colleges in California was to say, let's have different maths pathways as an option. And it could be that students take a data science course in their third year of high school and follow that up with a statistics course. That would be a really great pathway, and that would be valued by all those California colleges. We're seeing the same movement from different states across the country, including Alaska, where colleges are signaling that they welcome students taking a data science statistics pathway. If a student is going to be an engineer or a mathematician, they probably should stay on that calculus pathway. But for the rest of the students, which is the majority of college students, they would be very well served by a data science pathway. But one of the things I love about data science is this. In mathematics, the field I've always worked in, I think we could all agree that the overall communication that goes out in society is that only some people can get to the top levels of mathematics. It's very exclusive. And it, over the years, has also been very racialized and gendered. But data science is very different from that. And all the communication that you see is that anybody can become a data scientist. You can take courses online and become a data scientist. You don't have to have done well in school. So I love that communication. We work with a group at Stanford called the Women in Data Science Movement, WIDS, and they're very concerned to make sure that data science as it rolls out as a field doesn't look like mathematics and the way that has rolled out. So they've made this film for teenagers or kids in schools to watch, and it's really showing the value of diversity inside data science. It's also introducing people to data science. What is it and why might it be interesting? So I thought I'd just play this film for you.
I may not have set the audio up right. Just let us know if the audio works here. Let's see.
Do we want to go out and go back in? I'm not sure with.
Let's just see if it works.
Okay, so this is a great one to show the kids, to have everybody watch, or
Good
just
discussion piece.
just introduce data science to everyone. So before we get into some more resources for you, we thought we'd just watch this. Erica, maybe you can give us a thumbs up if you hear the sound.
Okay,
Here we
sounds
go.
good. I'm ready.
You should hear sound now.
I'm not hearing any
Okay.
sound.
Let's fix it.
All
We're
right.
going to go out.
All right, let's.
Let's see. Stop sharing.
So while Kathy does that, I can just
Okay.
tell you that
I think we've had some trouble before.
since we have started this initiative on our website around data science, data education, we've developed a whole range of resources at UCubed, and Kathy's going to be sharing some of them with you.
I see no, in Zoom, there's a audio
No.
switch. You can, it's already sharing. Mute video.
Do you
wanna-
want to talk a bit about?
Yeah, let's, how about go here, it says mute, and see what choices we have. Yeah,
I already
think
went there.
the big thing is,
Those are the
what's so
choices.
intriguing about this is if you look online, you'll quickly see and do some searches, people that are saying, oh, this is what I'm doing now. They actually have studied data science on their own through online courses, and they're now working as a data scientist. And so it's really an exciting time for students to say, hey, I'm interested in something, and I don't necessarily have to have that university degree. I'm not saying that university degrees aren't great for kids. Many universities now, it seems they're all starting to add data science degrees. But for many years, people have been getting into this field inside the workforce without getting those degrees, just learning. And it involves data visualizations and telling data stories. Joe will talk more about that in a little bit. But in this video, if we can get it to work, we will be able to, yeah, there we go. Can you hear us now? Okay, so we're not going to try to play the video. Something just goes badly when we do that. We'll give you a link that you can put in. Now, we can't hear you now.
Oh, now you can. That was my
Okay,
fault.
great.
Sorry.
Okay.
Should we just continue on from that time?
Perfect. And then
Yeah, we're still recording.
Yep. And do you want to put the link in the chat or send it to me after?
Sure.
I can put it in
The chat
Oh.
right now. You're not in though, and we should get back
no,
and
I'm
finish
not in.
this.
Yeah.
Yeah, we'll give it to you after.
Okay. Yeah, no
If that's
problem.
okay.
Yeah, you bet.
Sorry, everybody. We will definitely watch the video that we'll provide, and it's just and have the kids watch it and see what they think. Okay, come down here, and audio should still be fine.
So in the classroom, something that, first of all, students are very interested in real data and being able to make sense of the world around them, just in any case. But it becomes even more interesting for students as we introduce data through our website in an investigative cycle, where we encourage students to ask a question of some data, to seek out patterns where they bring their mathematical knowledge in and also make meaning of the data. It's not like other maths questions where you just produce an answer and it's gone, but you're interpreting it, and then you communicate and share with others the data in some interesting ways. So it's really a very interesting cycle for students to engage in. This is another way that we're communicating this data cycle, that students ask questions of data, then they think about what kind of data do we collect. There are two kind of types of data, one of which is number data. You might be thinking about the size of books in the room, and that would give you number data. Or the other type of data is called categorical. That's the type of data where you might go around and ask people their favorite color, and that would give category data. So there's different types of data students can learn about, and they think about how best to collect it. Then how do they organize it well, what patterns are in the data, and think about ways to communicate it. Some different examples in kindergarten. One example from our books is just asking students to sort buttons. This is where they're learning to think about the way data, what counts as data can vary. Variation is really the key idea inside data science. And here we see an example of a young student who sorted out buttons in these ways. So you can see she's used color, she's used size, she's used like the type of buttons. So this is where students are learning about what's called variables and how they can vary. And this is real data, and they learn to sort things and think about difference. These are important ideas for young kindergartners. As we move up through the grades, an activity we have in our book 1 is to sort trash and think about the ways that we can recycle. That's a really good data point. We suggest that students can measure, and maybe they measure using Cuisenaire rods or measure using something around them in the room, or it could be a ruler. And as we go up through the grades, we have activities all through the grades on our website. This is one where we collaborated with the Monterey Bay Aquarium, and they have recorded whales, and you can play the video, watch the whales as they're swimming through the ocean, and see that graph changing above. The graph is tracking the whale's movement. So it's really nice to be able to bring in real data and real examples from the world that students learn to make sense of.
Pause on that one, because
really engaging.
You were talking about the data cycle, and one of the things I love about this is even the scientists, they said, we don't see what whales are doing all day. We can see only a little bit when they come up to get air. And so what's going on? And so students can learn about this. There's scientists asking a question, figuring it out. How are we going to collect this data and not harm any whales? And how, what can we learn from it? And so there's all kinds of videos and things to look at on these links. And then, of course, the mathematical analysis that they're doing that students can interact with, because they can see how the scientists have visualized the data. It's a wonderful activity.
There's also videos to watch where you can hear from the scientists, how did they collect data from whales. So you can really make it a fully engaging, immersive activity. And then just before I hand over to Kathy, I wanted to share that we have a free high school course on our website. It's also involves completely free tools. We were guided by a team of data scientists. It's a project-based course. There are 8 units that you see there. It's really playing an important role in schools. Particularly, it offers a course for students even if they weren't tracked into a high group in middle school. And so it's really disrupting a lot of the inequities in schools. We launched our course a year ago. We were kind of surprised. We already have over 160,000 students taking it across the US. And you can see from the data that it's a diverse group of students who are taking data science, which I love. As I said, students can use data from their own communities. There you see a beautiful Alaskan picture. And not just use data that's given to them. They can go out and find data and ask questions of that data. And I have a little online class if people would like to learn more about taking a data perspective. But I'm going to hand over to Kathy, who's going to share a few more of our interesting resources.
Yes. Oh, my PowerPoint disappeared. Oops. All right, let's just... Interesting. Okay. Sorry about that, everybody.
That's mine.
No, that's got mine in it too.
Oh, okay.
We combined them, but then we,
Yeah,
I guess somehow in the flip over, we opened the wrong one. So we'll fix this right away. There we go. All right. So what I was going to talk about is some more resources we have on our website. And one of them is Data Talks. And we've talked about Number Talks, and Joe shared about the importance of dot talks and students being able to subitize and then groupize, see the number of dots. Here, Data Talks are just taking a visual data image and just having a conversation about it. It's very similar to doing a number talk. It doesn't take much time. I've chosen the 3 that are listed there for you, and there's a hot link to our resource page for Data Talks. But I have to say, any type of online media or even our phones have data for us. So you can find a data talk all around you in all kinds of different ways. So here's one example. So this data talk is one that we have on our website. I think it's a really important one because it talks about mindset in you. So down the left-hand side are the typical questions we will ask. What do you notice? What do you wonder? And what is going on in this data visualization? And there's all kinds of really important reading that happens for students, for all of us to learn. What do I need to pay attention in these things? What does that P is less than 0.05 mean? I notice it. What do I wonder about it? The coloring, the things that are provided to us. Notice that at the bottom, it has links to where the data came from. That's an important point for students to notice, to click those links, to talk about it, and just to interact with it. And what do I read, and what does this mean to me? So Joe, what's an important thing about this? This is one of the data visualizations that you feel very strongly that students are aware of. What story does it tell you?
This data graph actually shares some of the results from a free online class I have. And it shares that after students took the free online class, which is 6 sessions, so about 15 minutes each, they were completely different in their maths classes. So the treatment tells you about the group that didn't take the online class, and this is the one where this is wrong.
Oh, it's flipped.
Yeah,
sorry.
And ignore the first graph, that's wrong. But the second one,
I took that off our website this morning. Graph is wrong, going in my notebook.
But something really important to look at is that 63%. The average student in the group who took the online class, that is oh no, I'm sorry, Kathy, I was looking at the colors wrong.
Okay, good.
The average student in the group who took the online class scored 63% higher on their standardized test scores. So just taking that online class, nothing else changed in their lives. They took the online class at the start of the school year. At the end of the school year, they scored the average student in that group scored 63% higher than the students who didn't take the course. And then if you look at the graphs below, the teal is the students who took the online class, and you can see they were significantly more participating in classroom discussions. and much less likely to give up easily when they found challenging maths problems. So this is data from our online class, and we thought it'd be really interesting that students themselves make sense of this data and think about.
And talk about it. You know, what about mindset is important to them, and what do they know about it? There's a lot more information on our website about mindset. So this is a typical bar graph. You can find these. They're in the media. They're quite a common type of data visualization that we should all know how to read and extract information from, and then to question, is this accurate? What other resources should I look at to confirm this? And those things. So the second one I picked is this one. I decided to track my water usage for a 24-hour period and then try to illustrate it. So another thing that can be done is you can put these up. This is on our website. You can talk about it, and then maybe somebody wants to make one of their own water usage and figure out how they will tell the story. So data visuals today are very different because of the technology we have. There's a whole artful design and way that it can be done, and then, you know, to ask questions of it. So this is one we've provided. You can look at that, the color coding. Maybe there's something at home that you want to have study yourselves as a family, or have individuals take a look at it. But this is one we just wanted to include to prompt some curiosity. Another one that can be used, this is from Gina Rossi, a teacher we know. She just, when her students come in, she has a little chalkboard with colored chalk, and she just collects information from the children. In this case, it was breakfast, lunch, and dinner, and the drinks they had during the day. And she just made a little mark. This could be used for so many things. Maybe we're collecting eggs. I don't know. Maybe we're watching plants grow. Maybe in measuring them. There's all kinds of different things and all kinds of different ways we can choose to tell the data story. My kids are in their 30s now, but I would have loved to have done this when they were younger and collected a little bit of information as a family about maybe in the afternoons or evenings about how our day was. Anyway, some ideas there. This is another one we have on our website. One of Joe's undergraduate students created this one for us, taking some data from the national, the snow and ice data, and kind of overlaying it about Arctic sea ice. It only goes up to 2020. It would be interesting to carry this one out to current. And so I've got the titles up in the left corner, and those will be hot links to our page of Data Talks. All kinds of possibilities here. We like this one. I put this one in because it's very algebraic with that line going down, the regression line that's shown. Something interesting to look at, and we'll be talking about algebra across the grades in our next two sessions. So another tool that we wanted to make sure we shared with you today is one of our favorites. It's called CodeApp, and the URL is a hot link there for you. And what I love about data, this opportunity, Joe and I are passionate about this, is there are existing data sets you can study. There are you can also put your own data into it and analyze it once you know how to use the tool. This is a way for kids to get an entry level into, hey, I can be a data science. I can use CodeApp to create, analyze, look for patterns, and tell a data story. So,
or you need to just Google CodeApp and Concord, which is the root that makes it, and that should come up.
That Concord word is really important, otherwise you won't get it. So I'm just going to jump here to CodeApp, and can you see this, Erica, or do I need to reshare to share that? I think I need to reshare. So I'm going to reshare my screen and show CodeApp. So I'm on web browser here. It's codeapp.concord.org. This is what you'll see. And there's these three pieces. So sample CodeApp data sets is where you want to start. If you want to try inputting your own data that maybe you found taken from somewhere or that you have collected, you can go to the Try CodeApp. But right now I'm going to go to Sample CodeApp data sites. Now you can search for different content areas. I just leave them all on. I find them all interesting. I'm going to just show you how to use it by looking at these 4 seals. So they've taken data from 4 different seals, and they had trackers on them so they could get some geospatial coordinates here and put it in. And then the data is up here in the table. And there's all kinds of data on 4 different seals. So what I love about CODAP is all of these tools. And I know I'm going to be doing this quickly. There's a lot of helpful videos on this website. But I'm just going to take this graph over here. It shows the 4 seals, and I'm going to make it larger.
And you can just click on the graph tool, and that will appear for you.
I can get another graph.
You can drag and drop. It's very easy to use.
So let's just say, well, what's going on with seal number 1? If I click seal number 1 over here on the left, it's going to show me seal number 1's path in the Pacific Ocean during the time period that they were collecting data. Interesting. Well, maybe, you know, I want to look at another seal. I can move to that seal. Oh, that's interesting. It's a little bit different than the other seals. What's that? What's going on with that seal? That's seal number 3. Well, down here, you can click graph and get a graph, another one, and it shows all the data. What we love about this is you can just drag and drop. Let's just drag and drop and say, I wonder what's going on between distance and depth. And you can drag up to 3 variables into this, and that's just a whole mess. But my seal number 3, I can see some things about their depth and their distance. So now I'm wondering, well, maybe it's not depth. I can remove this, and maybe there's something going on with temperature. Oh, that's interesting. Well, who's this down here? What seal is that? And so I can try to see, is that seal number 1 maybe? Oh, seal number 1 definitely likes something different than the other couple seals. You can start, there's all kinds of variables up here. You can start to ask questions and look around and say, well, you know, try to figure out what's going on. There are tools that we can use to measure with this. We can say, oh, well, let's generate some different things, and we can do that. How about if I remove temperature for a moment? And I can show you more tools are going to prop up. We can start to put it in bins with a histogram. We can look at, well, where's the median? Where's the mean? Where's the average? Look at these different measures of central tendency. Mean, absolute. These are actually terms that are inside the standards for children to learn. I love this because it's real data. Perhaps it's something the students might be interested in and they can play. So we encourage you, there's a lot of resources on the website for you to look at to get some help with. What we thought that you might want to do is to try CODAP with something more than the seals.
Do you want to go?
Yeah, you talk about that.
Oh, you're okay. Little dog interrupting.
We had a helper come in and help us. Thank you. But what you can do is, if we go back to CODAP, you could go to the sample CODAP data sets, and a really good one to explore is this one about 27 different mammals and the data they've put in for that. This is a rich data set. It's very interesting. We've had a lot of people talk about how much they just love seeing it. In fact, in our PowerPoint that you'll have, you can actually see some of the work that people have done, or some of the things that I'll share this here for you, and see if I can get this right. There we go. Back to this. Here you can see we've got some samples of just some of the things. You can go to the mammals data set, use some of the tools, explore. Here's some things. The big thing is to ask a question. Here's a question over here. Does digesting meat require more energy and increase an animal's need for sleep? That was a question they had. So they started looking at the data in different ways, different views, to see if they could come up with some information about that. Here's another one. They got into box and whiskers and started to wonder about lifespan and the speed that the animal can go. There's categorical data, there's quantitative data. There's all kinds of different things that can be analyzed and just had fun with. So I'm going to stop sharing there, and we really hope you enjoy your journey into wondering about data science and just seeing what it what conversations it can bring up for you and your families.
Yeah. It's a really new data-filled world and lots of opportunities for students, and really a need for students to become, as I mentioned, comfortable with data so they can make sense of their world.
Yeah, all of us can learn something from more about data science. Encourage you to look at UCubed and the data science resources we have on our website. There's a lot of different things for you. In fact, some of those images, graphic images that Joe was sharing earlier, we actually have a little coloring book, something you can download. Students can color, and you can have a conversation at home about how do you protect your data? How do you make sure that, or even so students know about just really good family conversations that should happen for all kids. So anyway, thank you.
Yeah, thanks everyone. Bye.
Bye.